Hi, welcome to 3-4. I'm going to try and make this as quick as possible because we're going to do 3-4 in two flip videos. So this is part one. 3-4 is all about compound interest like we talked about in class, all right? So in order to understand compound interest, we gotta have a little bit of an understanding of what simple interest is. So let's review simple interest. Simple interest, our equation, just as a quick reminder, interest equals P times R times T. And then a graph on simple interest is a straight line where the y-intercept, your amount at 0 years, is your principal, right? It starts off at whatever your principal is. So it's a straight line, so it's not proportional. You know, that's something we talked about in topic 1. It's not proportional because it doesn't go through 0, 0, but it is a straight line. So it's just shifted up to whatever principal value, and then your x is time in years, and then your y is dollars, all right? So as more time happens, your dollar amount increases. Compound interest has a completely different equation, completely different graph. We have balance, B, equals P times the quantity, 1 plus R raised to the nth power. So B stands for balance, and you'll remember from 3-3, balance is interest plus principal. So you have to know what the interest is, and you got to know what the principal is to find your balance using the simple interest form. With compound interest, our equation gives us balance right off the bat, so we don't have to do any calculations that way. It just tells us what the balance is. We have to work backwards a little bit to say, okay, let's say our balance was $5,000 and our principal was $2,000. What's our interest rate? Not our interest rate, well, what's our interest? Well, if my balance is 5, I put in 3, I made 2. Okay, so it's different, not better or worse, it's just different because it tells us our balance instead of interest. All right, so balance equals interest plus principal, and then that P is the same as our principal from the simple interest, and our I is the same from the interest from the simple interest, same type of thing. All right, P in the compound interest formula stands for principal, so same P. R is still rate, and that's your percentage, but N now stands for number of years. So I wish there was a better explanation why we switched from T in simple interest to N for number of years in compound interest. Mathematicians are just funky, and sometimes we try switching things up. I don't have a good explanation. It just is what it is. Little trick to help you remember: number N. It doesn't matter. So it says if you want to plug a T in there, it'd be the same thing. Which variable you use doesn't really matter. All right, so let's go ahead and jump right into it. Suppose your grandma got you a government bond for your 13th birthday, compounds annually, 2.5%. was purchased for $8,000. How much will be worth when you're 18? So not the best birthday present, but you know, it's something. So let's highlight some important information. You're 13 years old right now, compounds annually at 2.5%. I forgot to highlight the annually, that's important. 2.5% is our interest rate, and it's purchased for $8,000. How much will it be worth when you're 18? So let's just start by writing out our equation for compound interest. B equals principal times the quantity, 1 plus R raised to the nth power. So balance, well, I don't know what the balance will be. That's what I'm trying to find out. We're trying to find out the amount that will be worth when you're 18. So balance is unknown. Principal, how much did we purchase it for? Well, grandma purchased it for $8,000, so has a principal of $8,000. Rate, 2.5%, which is the same thing as 0.025. And N, the number of years. Well, for this, we have to do some side work to figure this out. If you're 13 now, and you want to know how much it is when you're 18, how many years is it in there for? Well, between 18 and 13, you're going to subtract them to find the number of years in between them. So 18 minus 13, it's in there for 5 years. Okay, so now we can plug in our numbers. So balance equals 8,000 times the quantity, 1 plus 0.025 raised to the 5th power. And now we just got to simplify. So balance equals 8,000 times, so parentheses. PEMDAS tells me I have to do parentheses first. So 1 plus 0.025 is 1.025, still raised to the 5th power. So PEMDAS, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. There's no more parentheses, but I have an exponent, so I'm going to do 1.025 raised to the 5th power, which in what your calculator would be 1.025 times itself 5 times. So 1.025 times 1.025 times 1.025 times 1.025 times 1.025. So 5 times. So 8,000 times 1.025 raised to the 5th power. We're going to do that 5th power first. So 1.025 times itself 5 times is 1.131408. So I wrote out a lot of decimals here. Typically, if you write out 5 decimals, you're fine. So balance is 8,000 times 1.131408. So go ahead and plug that into your calculator. Your balance is $9,051.2657. And you remember, since we're talking about money, you cancel out anything less than 2 decimal points, because you can't, this is 26 cents. You can't give someone 0.57 of a penny. So you always, whenever you talk about money, you go 2 decimal points and then just chop off whatever's left over. Okay, so when you're 18, it's worth $9,051.26. So let's take it one step further. How much interest did you make? Well, if you started at 8,000 and now it's worth $9,051.26, balance equals interest plus principal. So it's currently at $9,051.26. I'm trying to find my interest, and I know my principal was 8,000. So to get I by itself, we're going to subtract 8,000 from both sides. These guys cancel each other out, and I have left over I equals 1. So 9,051.26 minus 8,000 is 1,051.26. So in 5 years, you made $1,051.26. So this is actually a pretty good deal, That's not bad for keeping money in a government bond for 5 years. It's not the best deal, but it's a good deal, okay? So let's do another problem. So I'm going to jump straight to homework problems. Renee deposits $500 in a savings account that earns 3% interest compounded annually. The table shows the compound interest and final balance for 3 years. Find the compound interest and account balance for year 4. So I'm going to highlight some patterns in this table, and you probably see even more patterns, but let's just look at these for right now. So notice that at time 0, you have no interest because it hasn't been in there for any amount of time. So I have $500 in there. So in the next year, I start off with $500, and I multiply by my interest rate. And really, there's a times 1, because we're looking at 1 year for all of these. But they don't write those in, all right? Because you don't need to multiply by 1. It's the same number. So for year 1, 500 times 3% times 1 year, I made $15. So my final balance is 500 plus 15 gives me $515. So notice the pattern. The final balance from a previous year starts off the amount of money that you go for column 2, your compound interest for the next year, right? And this is because in compound interest, you make interest on your interest. So in simple interest, all of these right here would just be 500. You'd always make 3% on $500. You would never make interest on your interest. In compound interest, you make interest on your interest. So year 2, you make interest on the original 500 plus the $15 from year 1. Okay, so that pattern continues, and you'll see end of year 2 is the start of year 3, end of year 4, year 3 is the start of year 4. So let's use that pattern to fill in. So 546.36. Now we're going to multiply by 0.03. Notice that these are all times 0.03 because it's the same interest rate. So 546.36 times 0.03, I made $16.39 in year 4. So notice that the interest rate goes from 15 to 15, not the interest rate, the interest amount goes from 15 to 1545 to 1591 to 1639. So I'm making more and more money each year, okay? So another pattern you'll see is the final balance for year 0 for the previous year plus the interest made in a year will give you the final balance in the next year. So in this case, 500 plus 15 gives me 515. And it keeps going over and over and over again. So let's get rid of those. So the same pattern we'll see again. So 515 plus 1545 gives me 530.45. 530.45 plus 1591 gives me 546.36. 546.36 plus 1639 gives me 562.75. All right, so tables are great, but there's lots of room for error in here. And if you're doing 30, 40, 50, 100 years, there's a lot of rows and lots of calculations that could take a long time. So let's try this problem using our equation. B equals principal times the quantity 1 plus rate times raised to the n power. And let's plug in what we know. Well, our balance, we're trying to find that out. Principal is 500, rate is 3%, n is 4, okay? Because it's 4 years. So now we just solve. PEMDAS tells me parentheses. So balance equals 500 times 1.03, because 1 plus 0.03 is 1.03, raised to the 4th power. PEMDAS, parentheses are done, exponents next. 1.03 raised to the 4th power is 1.03 times itself 4 times. So B equals 5,000 times 1.1255. Okay, so now we go into our calculator, plug that in. $562.75, which is exactly what we got in the table. Okay, so if you look at the two equations, a lot less work, a lot less areas where you could possibly make mistakes. In this question, Ben deposits $200 into an account that earns 3% interest compounded annually. Terrence deposits the same amount into an account that earns 3% simple interest. Compare the account balance after 2 years. Who will have the greater balance? So let's highlight some information. Ben put in $200, 3% compounded annually, 3% compounded annually, compound interest. Terrence, same amount of money, so still $200, 3% simple interest. So he's not getting interest on his interest. So let's look at Ben's account first. So Ben, balance equals principal times the quantity 1 plus r raised to the nth power. I'm trying to find my balance. I know my principal is 200. I know my rate is 3%, so 0.03, and it's in there for 2 years. So 200 times the quantity 1 plus 0.03 raised to the 2nd power, parentheses first. 200 times 1.03 raised to the 2nd power, PEMDAS, exponent next. 200 times 1.0609. Go ahead and multiply that. Balanced. Ben has $212.18 in his account after 2 years. All right, so he started off with 200, goes to 212.18. He made, his interest was $12.18. Terrence doesn't have compound, he has simple. So simple interest, I equals P times R times T. We're going to have to do some work here. So we need to know his balance, not his interest. So we're going to have to find the I and then plug it in to the I in the balance equation plus his principal. So it's one more step added. So interest is 200, because that's my principal, times 0.03, which is my rate, times my time, which is 2 years. So 200 times 0.03 times 2, work your way across. 0.03 times 2 is 0.06. So interest equals 200 times 0.06. 200 times 0.06 is 12. So his interest rate is $12. So his balance, if we plug that interest of 12 into our equation, balance is interest plus principal, $12 plus 200 originally, he has a balance of $212, all right? So Ben made $12.18, Terrence made $12 even. So it's really, really, really close because we're only looking at 2 years. If you look over 100 years or 50 years, Ben's account will be significantly bigger because he keeps making interest on his interest, and Terrence never makes interest on his interest. He only makes interest on his principal. All right, so whose account has a greater balance? Well, Ben has more money, so Ben's account has a greater balance. All right, that's it for 3.4 part 1. 3.4 part 2, we'll talk about what happens if it's compounded not annually. Let me know if you have questions.